Hi everyone, welcome back to Study House Academy's YouTube channel. Today, we're diving into a crucial topic for Secondary 4E Math, probability. Whether you're preparing for exams or just need a refresher, we've got you covered with everything from basic probabilities to combined events, diagrams, and the rules of probability. Let's start with the basics. Probability measures how likely an event is to happen. The formula is simple: P, event, equals number of favorable outcomes / total number of outcomes. The complement of E is the set of elements in the universal set that are not in E. Let's look at this example. A bag contains 9 counters, numbers 3, 6, 24, 33, 48, 56, 77, 81, and 98. A counter is selected at random from the bag. By using set notations, find the probability that the number is A, less than 50. B, divisible by 4. C, not divisible by 4. Solution for part A. We list numbers less than 50, 3, 6, 24, 33, 48, so there are 5 favorable outcomes. Our probability becomes 5 out of 9. Solution for part B. Let B be the event that the number is divisible by 4. B has 3 favorable outcomes: 24, 48, 56. The probability becomes 3 out of 9. Solution for part C. To find the complement of B, we take 1 minus the probability of B, which will be 1 minus 1 out of 3. The answer is 2 out of 3. Next, let's talk about combined events using diagrams, like possibility diagrams and tree diagrams. These tools visually represent all possible outcomes, especially when we're working with 2 or more events. A possibility diagram can be used to represent all the possible outcomes of a random experiment that involves 2 events. Imagine we throw 2 dice, one white, one red. The white die has faces marked 1, 2, 3, and 3, and the red die has 1, 2, 4, and 5. By mapping out all outcomes using possibility diagram, we can see that only 2 outcomes give us a total of 6, making the probability 2 out of 16, or simplified to 1/8. The probability of total score is a prime number is 9 out of 16. The probability of total score is not a prime number is 1 minus 9 out of 16, which is 7 out of 16. For events that happen in multiple steps, a tree diagram is extremely useful. A tree diagram can be used to represent all the possible outcomes of a random experiment that involves 2 or more events. Example: a bag contains a yellow ball and a blue ball. A ball is chosen at random and then put back into the bag. The process is carried out 3 times. By drawing a tree diagram, find the probability that a yellow ball is chosen every time. Exactly 2 yellow balls are chosen. No yellow balls are chosen. By drawing a tree diagram, we can see that there are a total of 8 possible outcomes. The probability of a yellow ball is chosen every time, YYY, is 1 out of 8. For the scenario where we want exactly 2 yellow balls and 3 draws, the tree diagram helps us see that there are 3 favorable outcomes for this: YYB, YBY, and BYY. This gives us a probability of 3/8. The probability of no yellow balls are chosen means the combination needs to be BBB. That will give us a probability of 1/8. Now, let's move to the addition law of probability. When considering the probability of 2 events happening, if they cannot occur at the same time, the 2 events are mutually exclusive. The formula is simple: P, A or B, equals P, A, plus P, B. Example: a bag contains 10 red marbles, 5 blue marbles, 4 green marbles, and 3 yellow marbles. A marble is chosen at random. Find the probability that it is a red marble. It is a green marble. It is a red or a green marble. It is neither a red marble or a green marble. Here's the solution. Total number of marbles equals 10 plus 5 plus 4 plus 3 is equal to 22. Probability of a red marble equals 10/22 equals 5/11. Probability of a green marble equals 4/22 equals 2/11. We can use the addition law of probability to find the probability of either a red marble or a green marble. Probability of a red marble or a green marble equals 5/11 plus 2/11 equals 7/11. Probability of neither a red marble or a green marble equals 1/7/11, which is equals to 6/11. Finally, let's discuss the multiplication law of probability for independent events. Two events are considered independent if the outcome of one of the events does not affect the outcome of the other event. If two events A and B are independent, P, A, and B equals P, A, multiplied by P, B. For instance, let's say we're picking representatives from a group with teachers, boys, and girls. Calculate the probability that both representatives are boys. Both representatives are not boys. One representative is a girl and the other is a boy. Here's the solution. In a class with a teacher, 5 boys, and 6 girls, if 2 are picked at random, the probability of both being boys would be 5/12 for the first choice multiplied by 4/11 for the second, giving us 5/33. Probability of both representatives are not boys is equals to 1 minus 5/33, which is 28/33. To find the probability of a girl and a boy, we need to consider both probability of a boy followed by girl and the probability of a girl followed by a boy. We use the multiplication law of probability. 5/12 by 6/11 multiplied by 6/12 times 5/11 equals to 5/11. And that's it for today's lesson on probability. I hope this helped clarify some of the concepts and gave you the confidence to tackle probability questions. Don't forget to practice and, if you enjoyed this video, hit that like button, subscribe, and leave a comment with any questions you have. See you in the next video.